So we've developed something that we call the system lifecycle evaluation. This is particularly important for people who do have legacy systems. And so one of the things we do is we come in and we catalog everything we have, because like we said before, if an asset goes down for whatever reason, you need to know what you have. You need to know make, model, firmware edition, and all that, because all that can impact how things get repaired or replaced. Can the thing be repaired? Can it be replaced? If so, what's the migration path if it can't be replaced directly? If the existing model doesn't exist, and these can all affect the configuration. One of the things that Troy mentioned is about version control, and this becomes very important because it's one thing if you have ICA as your controller, as your integrator, and we're making backups and we're keeping them on our site. So chances are, if something goes wrong, we've got a backup. But there can still be, if you have other people, if you have multiple companies coming in, version control becomes critical, because we come out there and we do some work, we got a backup. Somebody else comes in and does work, and maybe they make some changes. If we don't have that backup and your system goes down, and we come on site and we install the backup we have, because you didn't get a backup from the other guy, now what? Now all of a sudden you've got an old copy that may have errors that the other, that have to be resolved, or maybe there were system changes that are not reflected in the old code. So this is critical. So part of our approach. So there's several pieces. So the first is inventory. So we go through, we catalog everything that you have, every automation asset, every controller, every switch, every drive, all of it, anything that's connected to your control system. And then that also includes documentation, because in a lot of cases we go out to customers that have had older systems, and the system is either not well documented or the documentation is very well out of date. There's been a lot of changes that haven't been reflected on drawings. The design document is no longer representative of how the system works, or there isn't one at all. There's either the user manual doesn't exist, or is again hopelessly out of date, and that becomes a training issue as well. So we also catalog documentation. The next we do is a gap analysis. Okay, what are you missing? In some cases, when it comes to backups, there are some legacy systems where it's not possible to back up from the controller or from the HMI, that you have to have that original development file. And if that can't be located or obtained, that's a risk. So this is something that becomes a big problem potentially in the future. If system does get knocked out or taken out, whether it's temporarily or permanently, this becomes very difficult to try to deal with. Then once we have that, then we can go through a risk analysis, and then we start going through all these scenarios that everyone's talked about: weather events, energy release, force majeure, active violence, quarantine, whatever it is, whatever could have caused it, or just old part that burned out, and try to come up with an expected time to recovery. How long is it going to take you, based on these various scenarios, to be able to get your operation going again? And pointing out, where, so then you can identify what are the greatest risks, what are the least risks